The final step in using the modeling techniques that are built into Hach WIMS is to now look at, after we have looked at our oxygen analysis and solids production, to see if our clarifiers are going to be able to handle the solids that we're sending to it. So what I'm going to do here is the first step again is to develop something called a flux curve, which is nothing more than a settling curve. It indicates how stuff settles in your clarifiers given past performance. So in this case, I want to add a new curve. And I want to have a set of curves that allow me to select for each time of year as stuff or processes that are occurring in your system. So I'm going to go ahead and click Add a New Curve. What we want to do is we're going to do some settling, we're going to do some concentrations of your mixed liquor and your RAS and do settling velocity tests on that material to develop this curve. So what we suggest is you dilute your mixed liquor 50%, you do a 75% of your mixed liquor, you do your actual mixed liquor, then you do a 75% dilution of your recycle concentration, and then run your actual RAS concentration. So in this case, I'm going to go ahead and do that, and I've got some numbers here. So I'll say I'm going to run a concentration of 1,000 for my mixed liquor, and my settling velocity we'll say is 14.1. 2,000 concentration, and we'll say it drops to 11.4 at 3,000. We'll say I'm at 9, and it's starting to calculate as we go. I'm going to do a 4,000. This is a 4.6. That's 6,000. Going to get a 1.6, and we'll say at 9,000 we get a 0.8. We've got an excellent correlation coefficient of 0.985, and here's the curve. I've developed it on this date, September 9th, 2013. So I'm going to go ahead and, since the correlation coefficient on these laboratory tests is very good, I'm going to go ahead and click Save, and now I have a new flux curve that I can use that will predict how stuff will settle. So I have to develop a flux curve. I've done that. Now I'm going to actually be able to run the state point analysis, which is a fairly accepted way to look at your clarifier loadings to see if they're going to be okay. So I'm going to come in here. I get to choose any of my curves that I just set up. So I'm going to choose the one I just did. I'm going to say I'm going to run both clarifiers, and I'm going to go in here and say these are my operating conditions right now. I've got an influent flow rate of 3. I'm going to recycle 50%. I'm going to waste 0.5, and I'm going to run 2,500 as my concentration. I'm going to go ahead and click Plot, and all the state point analysis does is here's our flux curve. This is how stuff settles. And then we have these two lines that intersect at the state point, which is actually 2,500 is my mixed liquor. That's where this analysis gets its name. So if the area of this triangle defined by these two flow lines is underneath your curve, you're essentially good to go. So now let's go look at some different conditions that may cause us problems. So let's say, well, our flow rate goes way up. I'm going to say the flow rate goes up to 8, and I'm not going to recycle anymore. I'm not going to waste anymore. And I'm going to update my mixed liquor to 3,500. So now what happens is I'm outside the curve. I'm in a very bad condition. What this means is that the blanket's going to rise, and eventually if we don't do anything, it's going to overflow the weir, and we're going to have violations. So what can we do about this? Well, we can do a couple things. One is let's recycle, 3.5. Let's lower our mixed liquor back down to, let's say, 2,500, and let's replot this. So now what we see, doing a more normal RAS flow rate of 3.5 when we have a flow rate of 8, and we moved our state point or our mixed liquor over to 2,500, we're back in a good condition. Now again, we're getting closer to the curve, so the closer you are to the curve, maybe the little more at risk you will be, but in this case we've moved the triangle underneath the curve and we know that'll work. So again, you can play this what if analysis, changing your mixed liquor, seeing how it will affect your oxygen using oxygen analysis, You're going to see what solids you're going to produce out of the system and see if your clarifier can handle those solids. And that's really the end of the modeling techniques. It takes us through all three parts of that thing so you can model your system and see the what if analysis. If you change this, you can save money on oxygen, but then maybe you're going to overflow your weirs on your clarifiers, so you can play that game on the computer instead of testing it on your system. Thank you.